Hello and welcome to Integrated Math 2. This is the first video of the year. We're going to learn about symmetry. And the thing about these videos is very important that you watch them and not just put it on mute to see me flapping my arms everywhere, but that you actually listen, put in your earbuds if you need to, but listen to what I'm saying and actually write into the packets to fill those in. Those are going to be checked, and these are going to be very important during the year. So, first thing is symmetry. There are three types of symmetry. Symmetry basically means being able to look the same after something is done to it. The first kind of symmetry is called reflection symmetry. And reflection is basically flip. It's when we can draw any kind of reflection line that flips the figure back onto itself. Sometimes that line looks like this and we can flip it this way, or maybe the line's going horizontally, or maybe even diagonally. But if we can flip it over a reflection line, and it looks the same as what we started, then we would say that that figure has reflection symmetry. So for example, this one here does have reflection symmetry because if this line is here and I flip it over, I'm going to end up with the exact same shape. This one's a little bit tricky because there's no reflection symmetry there. If I flipped it, it would be very different. There's also no reflection symmetry there because if I flipped it, it would be pointing to the left instead of pointing to the right. It wouldn't be the exact same thing. But this one is a little bit sneaky. It has a line of reflection right here. I could flip that. That doesn't look right. I could flip that diagonally and it would end up looking the same. So go ahead and draw that reflection line in. It does have reflection symmetry. The second kind is rotation symmetry, and that's a turn. Can I turn it a certain number of degrees and have it be the exact same thing? Ones that we see a lot are things like squares, right? A square has rotation symmetry because I could turn that square how many degrees for it to be the exact same thing? Well, all the way around is 360, right? A fourth of the way around then would be 90 degrees. We would say this has 90-degree rotation symmetry. It also has 180 degree, but we always talk about the smallest number possible. In a triangle, there's 360 all the way around if there's an equilateral triangle. Then a third of that way around is 120 degrees. We would say that has 120-degree rotation symmetry. What about something like this? Can I turn this shape in some way that would end up being the exact same thing? No. It's a weird shape. There's no rotation symmetry here. However, something like this, 1, 2, 3, 4, 5, five-sided thing is a pentagon. If they're all the same, it's called a regular pentagon. I could twist this 1/5 of the way around, and it would end up being the exact same. So 360 divided by 5, that is 72-degree rotational symmetry. The third kind of symmetry is called translation symmetry, and that's when it's possible to slide the figure so it maps onto itself. Things that go on and on forever usually have translation symmetry. So something like this, if I take this line and I slide it, well, it's still the same thing. It looks the way that it started. Because of these arrows, it goes on and on forever. So this has translation symmetry. If I had just endpoints and it was a segment, that does not, because if I slide it, now it's something different. It's in a different location. But because of these arrows, it goes on forever. This has translation symmetry. I would like you now to pause the video, try these four on your own, and then when you're ready, hit pause again and you'll check your answer. So go ahead and pause and try. And unpause and let's check your answers. This one here, does it have reflection symmetry? Yes, because I could draw something there that would reflect it. So it has reflection symmetry. And I could actually rotate it as well, halfway around the circle. So that is rotation of 180 degrees. Does not have translation. Even though these arrows go on and on forever, I really can't slide this. It wouldn't be the same thing. This one does not have reflection. I can't flip it in any way that would be the exact same. I also can't rotate it because These aren't the same heights. However, because it goes on and on and on, and it's the same pattern, I could take this much and slide it to here, and it would end up being the same thing. This has translation symmetry. The ones down here, this star, does it have reflection symmetry? Yes, here's a line of symmetry, or here's a line of symmetry. So it has reflection symmetry. Does it have rotation symmetry? Yes.
Okay, at this time, if you could head to your third period class, and that will start in 3 minutes at 10:04.
90 degrees, so we would say 90-degree rotation symmetry. 1/4 of the way around. The letter H, it has reflection symmetry here, it has reflection symmetry there. And it has rotation symmetry. I could spin it halfway around the circle. Halfway around is 180 degrees. So that is symmetry. Make sure you get all this in your notes. Have a great day.